All right, hey guys. I'm gonna start putting up some videos of me, the lessons that I go through, just to try to help you guys out. For this particular one, if you guys notice, I put up a couple of worksheets that you guys can get started on. I had a couple of lessons on con, just trying to get a couple of different resources out there. But I kind of feel like I want to just go through some things with you guys too. So the first worksheet I put up there was one of those pogols. That's the one where you basically go through and it walks you through, and you almost like discovery learn a little bit. But it's still talking about binary ionic compounds. The next two are just more practice. It's a super, super important thing. Usually, what I tell my classes is that you have to get good at writing formulas. To get through chemistry, you have to be able to write your formulas 100% of the time correctly. Like, you have to be able to write 100% of your formulas correct 100% of the time. Like, it's just such a big deal. I always talk about, what happens if a pharmacist writes a formula wrong. Then your whole thing's gonna be messed up. Every single part going forward in a chemistry class relies on you writing your chemical formulas correctly. If you don't write your chemical formula right and you try to balance an equation later on down the road, it's not going to work out. You're going to get the problem wrong. If you want to figure out the formula of mass, which is something we're going to do not too long from now, if you write the formula wrong, you get the problem wrong. Just plain and simple. It happens over and over and over again. So you have to be perfect at writing your formulas. Super, super important. Now, the good thing is it's not that bad of a thing to do. It's something to get used to, some tricks and some things that are kind of annoying, but you just kind of get used to it. Now, the ones we're going to start with first are what are called binary ionic compounds. When we say binary, we think the word two. Well, binary two, well, why? Because it's just two elements. So we're going to write formulas that are binary, so it's just two different elements. Ionic, meaning that they form ions. Remember that word from before break? We talked about ions. And they're compounds, so it's two different types of elements. So we have almost done this a little bit. Back before break, I had you guys draw some Lewis dot structures, and we talked about how those electrons moved and whatnot, and how they form compounds. Well, that's really the same thing we're doing. So for instance, if I took something like, I don't know, let's say we have barium. So I take barium, and barium, if I asked you, hey, where's barium at? How many valence electrons does barium have? You would take your periodic table and you go, oh, barium's right down here. So since barium's in the second group, it's an alkaline earth metal, it has a 2 positive charge. It has 2 valence electrons. So we're going to remember that. So if I drew 2 valence electrons right there, I have my barium. Now let's say barium gets into, gets close to, say, chlorine. Chlorine is a halogen. That means it's in group 7 on the periodic table. It's right over here. So that's in group 7. So since it's in group 7, then chlorine has 7 valence electrons. So I would draw this out, first 2 together, and then it just kind of goes around here. And chlorine has 7 valence electrons. So we talked about like electronegativity. We talked about some of those trends. Chlorine's a smaller atom because the more protons and electrons they pull together. All those different things we talked about before the break. What it does is it allows chlorine to pull these electrons from barium back over to itself because chlorine wants to obey the octet rule. So chlorine is going to take this electron and it's going to pull it right there so it can obey the octet rule. Well, barium still has another electron there. So chlorine is going to find another chlorine. Where there's one, there's usually more. And I take this chlorine right here. And what happens is this electron right here is now going to do the same thing. This chlorine will take that electron. So those electrons end up being there and there now. So now what happens is if barium loses 2 electrons, you guys know this already, this isn't new. So if barium loses 2 electrons, it becomes 2 positive. And if chlorine gains an electron, then chlorine is 1 negative. But I have 2 chlorines, so I'd write Cl 1 negative, and then I write another Cl 1 negative. Now when we write a formula, we don't want to write Cl. We don't write it like that. We just don't. In fact, when we write formulas, we're not going to do this whole mess. This is just to show you what's happening with the electrons. So what we're going to look at is we're just going to recognize our charge. So in this case, a 2 positive equals 2 1 negatives. Well, that has to work because in order for these electrons to all work out, whatever barium gives up, chlorine has to gain in some way. So those charges always end up having to balance out. So in this case, the way we would write this is we would write barium, and then instead of writing Cl, we're going to write Cl 2. We're not going to write both Cl's. We're just going to write BaCl2. Now, sometimes people will write the charges. You might even want to do that. Like some people like to write the charges right there. So we can say, okay, Ba, 2 positive, and then I have 2 Cl's that are each 1 negative. Some people like to do that just to try to keep it straight, just to remember what the charges are. You could, especially as you're learning it. Yeah, sure, go for it. But you don't have to. So usually what we do, like if I'm going to write out a formula, like I'll do another one real quick that is similar to this, but I'm not going to draw out everything else. So let's say I have potassium oxide. So in this case, I have potassium oxide. Now I'm going to show you the fast way to do this. I'm not going to draw out this. I'm not going to say potassium, okay, 1 valence electron, oxygen has 6 valence electrons, draw it out and show all these going, wherever the electrons go. Instead, what I'm going to do is I'm just going to look at my charges. I'm going to look at like these guys right here. So if I look at where potassium is, remember I had you guys label this on your periodic table. So periodic table, K, I have it, you guys have it written on your periodic table above there. You have potassium labeled as a 1 positive, which means that potassium tends to give up 1 electron. Oxygen, you have labeled on your periodic table, it's in group 6, you have oxygen labeled as a 2 negative. Well, simple math, 2 doesn't equal 1. So in order to make this equal this, I would need another one. So I'm just going to write another one right there. 1 positive, okay, 1 and 1 equals 2. That's not tricky. So now I know, okay, well, a 1 positive and a 1 positive, 1 positive and a 1 positive equals a 2 negative, which means when I write my formula, I'm going to write potassium, which is K. I needed 2 of them, 1, 2, and then I have oxygen, K2O. And that's how you write a formula. And it works like that, pretty much all the time. I'm going to write another example. Let's say I have aluminum sulfide. Okay, aluminum sulfide. So if I want to write a formula for this, I do the same thing. I grab my periodic table, I find aluminum. Aluminum is right over here, and it's in the 3rd group. So I know aluminum is a 3 positive. So it's a little bit trickier, because when I find sulfide, sulfide is actually right under oxygen. Sulfide is a 2 negative. This one didn't work out as nice. Doesn't work, it's not as easy as this one where I can just add 1 right here, because a 3 doesn't equal a 2. So if my 3 doesn't equal a 2, that means I need another sulfur. But if I put another sulfur, now all of a sudden I have a 3 positive, but I have a 4 negative. That doesn't work. So that doesn't balance out. 3 doesn't equal 4. So that means I'm going to need more aluminum. So if I take another aluminum, that didn't work either, because now look at this. I have 3 positive, 3 positive. That's a total 6 positive. That means I have 2 aluminums giving up 6 electrons. Well, where do those electrons go? Well, I only have 2 sulfurs so far. That means they gain 2 and 2. That's only 4. But if I have a 3rd sulfur come in, look what happens. 3 positive, 3 positive. That's a total 6 positive. 2 negative, 2 negative, 2 negative. That means in this process, if you were to draw it out like we did on one of those, the ionic bonds worksheet from last unit, you would have all these, you would have 2 aluminums, 3 sulfurs, and their arrows going all over the place. So instead, we can just look at it this way and go, okay, 6 equals 6. That tells me I need 2 aluminums and I need 3 sulfurs. And we're good. So we have Al2SO3. Okay, one last type of problem that I want to talk about that you guys are going to have to just recognize. And on probably all of those worksheets, there's examples of them. And it's when we get to these ones that I had you highlight that are in the middle. I had you highlight like from chromium over. Chromium was a 2 positive or 3 positive, manganese 2 positive, 3 positive, all throughout here. The ones that I had you highlight that can have multiple charges. What you're going to recognize with those is that the reason we highlighted those is because they can have multiple charges, and when we name them, we're basically going to look at this. Let's look at this. If I write copper, Roman numeral 2, chloride. The nice part about this is that this Roman numeral, we don't even have to look at a periodic table anymore. This Roman numeral tells us that copper is a 2 positive. So I automatically know copper is a 2 positive because of this Roman numeral right here. So copper is 2 positive, Chlorine, I have to look at my periodic table. So chlorine, if I look it up, it's in group 7. That's my 1 negative. So now I look at that and go, okay, well, 2 positive, 1 negative. I need another chlorine. 2 positive, 2 negative. This one would be CuCl2. We're good to go. So again, just look at your charges. Usually what I tell people when they're writing formulas for binary ionic compounds, we're just looking at your charges. You check your charges and you make your charges balance. If you can make your charges balance exactly what I'm doing here, you're going to be able to write formulas. And just make sure you're always just balancing your charges. Don't look at potassium oxide and just go, oh, look, potassium oxide is just KO. You know, it doesn't work that way. You have to balance your charges every single time. So that's something to practice, something you guys really need to get through. And then just, like I said, you just practice it. You have some worksheets that I gave you guys that you can go through. Now, I can talk about naming. If you name them, it's actually pretty easy. I'm going to put a PowerPoint up. The first 8 slides are about ionic compounds. You can just read through the PowerPoint and look at some examples. But if you want to name them, you just go the other way. K2O, potassium oxide. You change the last 3 letters to IDE. So potassium oxide. If I gave you Al2S3, in reverse, it's just aluminum sulfide. The tricky part is when you come down to something like this, you see CuCl2, and you go, oh, wait a second, copper is highlighted on my periodic table. Since it's highlighted, I have to figure out what Roman numeral it is. So now you have to go back and reverse and figure out what the charge was. Well, if you recognize chlorine was a 1 negative, you can kind of reason your way through and say, okay, well, chlorine is a 1 negative, so that makes this a 2 negative, which means this had to be a 2 positive. So when you name it copper Roman numeral 2 chloride. And that one might take a little more practice, you know. So that's something else you just want to kind of look at and just practice and get used to when and when not to use a Roman numeral. All right. Like I said, if you run into any problems with these, I'll be on the computer every day from 11 to 12 for your guys' class. You can shoot me emails at any point asking me for help if you're not understanding something. If you wanted me to jump on the computer and just do a meeting, as long as I'm available at that time, I can jump on the computer and do one of the Teams meetings and try to help you out or whatever you guys need at any point. But formula writing, like I said, is going to be super important. We're going to go to the next step. I'll put another one up here pretty soon where we talk about molecular compounds and how they're different. Then we'll get into other types of formula writing, and we'll just try to go through this and just keep working. So with that, I think you have enough information to do those first 3 worksheets. You can practice on Khan Academy too. I put a bunch of those lessons up as well. And we'll just keep going. So I will talk to you guys soon. Take care.